Hello everyone. Welcome to our channel. In our previous videos, we solved some interesting exponential problems. Starting from today, we comes to solve some interesting problems that are related to logarithms. As shown on the screen, the logarithms are the inverse of exponentiation. Thus, two conditions must be set for logarithms. Number 1, its base b must be greater than 0 and not equal to 1. And number 2, its argument a, that is, the number you are taking the log of, must be greater than 0. Otherwise, as we know, a base of 1 would not create an exponential function that can be inverted. The argument must be positive, as there is no real power that can be raised to a positive base to get a negative or 0 result. Next, we briefly review the logarithms rules. Product rule, multiply will result in adding logs. Quotient rule, divide will result in subtracting logs. Power rule, it means that exponent comes forward. Root rule, the root becomes a fraction. Change of base shows the conversion of any base. Identity rule, log of base results in 1. Zero rule, log of 1 results in 0. Inverse rule, log and exponent undo each other. Exponential form, log and exponential can be exchanged. Domain restriction, logs need positive inputs. Now let's take a look at a logarithm problem shown on the screen. It comes from problem 7 on this year's AMC 12B. We're asked to evaluate a sum from equals 2 all the way to 255. So how should we approach it? Let's think about it for a moment. Let us have a look at the solution step by step. Actually, this is a classic example of a telescoping series. A telescoping series collapses just like a telescope. Most of the terms fold up and cancel out, leaving only a few surviving pieces. This cancellation process, where part of each term cancels with part of the next, is known as the method of differences. The example of a telescoping sum shown on the screen illustrates the key idea, the central insight we need for the problem. Now, let's watch the video and break down the details step by step. What do you think for this problem, the solution key in sight? Leave a comment below, and don't forget to like, share, and subscribe for more fun math problems.